Distance formula. Suppose that P, point x1, y1, and R, point x2, y2, are 2 points in the coordinate plane. The distance between P and R, written d of P, R, is given by the distance formula, where the distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Let's take a look at how the Pythagorean theorem is used in this. Here you see a Cartesian coordinate system, and what we have are 2 points put on the plane. We have x1, y1, and x2, y2. What we need to do is find the distance between these 2 points, which lies along this line. In order to do that, we'll form a right triangle. Drawing in the base of the right triangle here, in the horizontal direction, and the height in the vertical direction, we know that this x value is x1, and this x value is x2. So to find the distance from this point to this point, we would write it as x1 minus x2. Then, doing the same thing in the vertical direction, this point here is y1, and this one down here is y2. So to find the distance between here, that would be given as y1 minus y2. So, using x1 minus x2 as one side of the right triangle, and y1 minus y2 as the other side of the right triangle, we can then use the Pythagorean theorem to find the distance between them, which is the hypotenuse of the right triangle. So that would give us x1 minus x2 squared plus y1 minus y2 squared equals the hypotenuse squared, and then taking the square root to find the distance, we have the distance formula. Now you may notice that the difference x1 minus x2 isn't exactly what we had before, because in the graphic we showed earlier it had x2 minus x1, but keep in mind when we square this, the results do turn out to be the same. So this is an equivalent form. Another important formula that we need to look at is called the midpoint formula. Let's take a look at that. The midpoint formula. The midpoint of the line segment with endpoints x1 and y1 and x2 and y2 is given by x1 plus x2 over 2, comma, y1 plus y2 over 2. So let's take a look at an example that asks us to use the midpoint formula and the distance formula. Here we're asked to find the distance between point P and Q and the coordinates of the midpoints of the segment joining both P and Q. We're given that point P is the point -8, -2, and point Q is the point -3, -5. So in order to find the distance between them, what we need to do is set up the distance formula. So the distance formula is equal to the square root, and now what we need to do is take our points and subtract the x values. Well, the second x value that we were given on point Q was -3, minus the first x value of point P was -8. So that's our x2 minus x1. And then to that we have to add our y2 minus y1. Well, the second y value was -5, and the first y value was -2. So we have -5 minus the -2, and then we need to square that. Simplifying this, we get the square root, and then -3 minus -8 is really -3 plus 8, and -3 plus 8 is 5. So we have 5 squared, plus, and then over here in these parentheses we have -5 minus a -2, which is -5 plus 2, and -5 plus 2 is really a -3, so we need to square that as well. Working this out further, we have the square root of 25 plus, and now -3 squared is +9, so it's the square root of 25 plus 9, and now adding the 25 plus 9, we find that the distance between these 2 points is given by the square root of 34. Along with finding the distance between these 2 points, we were also asked to find the midpoint. Let's take a look at the midpoint formula. To find the midpoint between these 2 points, remember, the midpoint is given by x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So using this formula with the points that we were given, x1 is given to us as the value -8, plus x2, which is given as the value -3, all of that divided by 2, and then y1 is the value -2, plus y2, which is the value negative 5, all that divided by 2. Well, negative 8 plus negative 3 gives us negative 11, and negative 2 plus negative 5 gives us negative 7, and then dividing both of them by 2, we end up with the midpoint of this segment is located at the coordinate point negative 11 halves, negative 7 halves, or if you change that into a decimal, it would be negative 5.5, negative 3.5. In this section, you've gotten a chance to look at the real number system. You've seen useful formulas such as the distance formula and the midpoint formula as well. You should continue practicing by doing the exercises in your textbook, and I'll see you next time.